to find approximately like this size of chunk of data in your computer, right? In case of Python, you need to know each element which type it is and later put again like that. So in this case, it's different. You understand what I mean? Later we have like NumPy have perform element by element multiplication. So what it means that, for example, when you want to use NumPy, handles the loop internally in the CPU, and you can achieve the max performance, and it do it based on what it's called parallel. What means that if you have, for example, for loop, it will take the first 16 numbers and do it automatically in the same time, the next 16 numbers in the same time. So when you do this, you increase so much the computational right now, because if you do a for loop, you are doing each one iteration, but differently. And for the matrix multiplication, that you cannot see, but whatever, the operation, very important is that no can differentiate between, if you want to do a matrix multiplication, you can use like element by element, and also you can do the matrix product, like the dot product in NumPy, right? So it's very smart that you can do that, and you know how to handle this. It basically takes the row, all the rows for the matrix, and it put in a single row. What means that in terms of doing a double for loop and loop that you do manually, like rows for column, you get the first value, blah 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 blah. But it does that. It does in a single row, so you have times complexity O(n) and no n squared, because like it's obviously. And later you have lining, and later start with pandas, blah blah blah. I say this is simple, but for new students, like new people, can be interesting. This is an introduction, like just introduction. Just introduction of pandas and NumPy. Not so detailed. So today you the sun will not be here. So. I want to talk later with more deep, but I don't have time. I don't have time to make it. So your PhD first year? Second year? Oh, you already in second year? You? Master's second. What you are doing? The robot, right? Yeah. Not planning YouTube. We got it.
谁讲的？还
I try to.
他就是因为我们要好多不同的照片。
What? Two different. What's the
有拍对
visualization? for data analysis, so I develop algorithms to detect with geometry to detect craters geometrically. So data can be degraded, so it detects the craters.
I didn't go to this weekend. It's not even the weekend yet. Previous weekend. Yeah. Even professor, Vietnamese professor. Vietnamese professor didn't come for like months. Like even a year. Yeah. He showed up. Yeah,
Let's start today's weekly meeting. It's okay. The remote team, can you hear me?
I think
Yes, we can hear you. Yes.
Okay, nice. Yes. And I think one just additional thing is today's last day for Joshua.
Yes.
So they say yes. Thank you so much for coming and doing the internship. I'm not sure how to say it more appropriately. So maybe later after the weekly report, you can do some just feedback or some experience sharing. Okay. So let's do the weekly report first.
私はまず未来ワークスの方は、イベント記事を、作成したイベント記事を本番反映したのと、あとはまた次の新しいイベント記事を作成して、今テストサイトにアップして、お客さんに確認に来ていただいている状態です。であとは他に、SMBC さんから依頼が、ワードプレスの記事を数に取得する、コードを書いたりドキュメントを用意したりしました。あとは、滝根さんのフレームワークの入れ替えを行ったのと、行いました。で、来週の予定としては未来ワークさんの記事をまた、本番反映するのと、あとは月次報告書とか、正規報告書について書きます。以上です。
今週は宮泉さんの、メールの移行についてちょっと電話何回も、複数で対話していて、移行今進んでいます。で、リンクブレンさんの、修正も進んでます。で、あと、山寺さんが依頼で、コードブルー2015の方に参加しました。で、来週の方も、宮泉さんの方から多分、複数のお問い合わせがあって、それで対応を続くことと、あと、引き継ぎリンク病院さんの修正して、月末納品できるように頑張ります。以上です。
So, due to some sickness and some other projects to post, so antibody project only finished the record database structure, and I post a little bit for the camera picture caption function. I will continue to do it for next week. So, say the post, we will have exception on tomorrow and to Saturday in Koriyama. So, just about not just us, the whole kind of like exception is related to the robot and space. How do you say aviation and the space? So it's kind of like a festival for them. If you are interested in those fields, you can just also take a look there. I think if you take this, Saturdays will be open for general public. So you're welcome to join, and you can take those invitations from here. So yeah, that's all from my side. And
for the dashboard, I was mostly working with Glucose, so only a few changes, and I did some refactoring for some session timeout, additional data affection, and I also added a new AI analysis for correlation analysis and corresponding heat map. Can you go to the next slide?
Yes.
Yeah, the top right screenshot is the new heat map and some other UI stuff below that, but I did not take a screenshot of it. Okay, each of this.
For the Kobe video project, I implemented
Hashi-san, they cannot hear you well. Maybe for some reason again.
Okay. Can you hear me?
yes,
Yes.
Okay. Sorry for so for Kobe video project, I implemented editor slide content, and also I added the import import video model UI, and also I also added the feature to add clip to editor when the video is imported. And for the next step, I will implement the video for watching the video, playing the video UI, and also the feature for the synchronize the video element and clip 以上です。
For the idle sim drone project, tomorrow and the day after tomorrow, we will join the Fukushima robot exhibition with Tom, with Nika and me and Victor. And for the work, we are working for the SOAM hardware assemble and test, and also continue the sim to real deployment, and also the Unreal plugin development. Thank you.
Yes, and as for the A part, we, as Gan-kun said, that tomorrow we are presenting at the RoboFesta Fukushima in Koriyama. So took some time to prepare and refresh the presentation. And also we continuing with the curriculum learning for the agent and the stages for the progressive training. 以上です。
For the San Francisco project, I completed the issue 2511 this week, and for the next step, I will complete the 2480 and 2451 by next week. 以上です。And for the part-time dashboard project, I finished the refactor the front end pull request, front end code pull request, and for the next step, I will implement the table sort feature. 以上です。And for the EJQ project, I share the analysis report of the survey with Yamada-san, and if Yamada-san check it and accept, then we will make a plan for the meetings. 以上です。
Good evening, everyone. While last week I was learning about the drone project and the Instagram social media project and the website, this week I learned about the JAXA project and the medical project, which were both very interesting and inspiring. Also, I began working in the Unreal Engine on the cinematic scene. Unfortunately, the PC crashed and the video material got lost, so I cannot show something. Yes. And also I tried supporting everyone and making coffee every day and just sticking around, learning as much as possible. Yeah, and maybe this is also because, as Tang-san already said, this is my last day. I got the opportunity to thank you everyone because, yeah, even though it was very short, my time here, just 2 weeks, basically nothing, I learned quite a lot, not only about the company, but also projects, about new software I can learn and about more in the future, and how to work on the projects, what it has to be considered, how the company can be very various projects at the same time, but also about the chemistry in the company and weekly meetings, morning meetings, everything is very, very interesting, and I learned a lot. And everyone has been super nice to me. I appreciate that. I really have felt welcomed from everyone, and yeah, thank you so much.
This week I helped
I have the interest available for work and looking for this. In the last 2 weeks, I've traveled to Tunisia. I'm still in Tunisia, and probably I will start working.
We can't hear you properly.
No? Oh,
Yeah, we
sorry
can
about
hear
that.
you very lightly, but not properly.
from Japan.
Oh, but I say you don't have a webcam. Because I'm not home, so the sound is not that clear. But yeah, basically, I will return to work not next week, but the week after. Thank you. Okay.
This week I give a task and I'm looking for a task if you have any questions. Please. Thank you. Last week I had a book and next week I will continue my lesson. Thank you. I was supposed to be working on the Blender like sub project thing, but because of like exams and the assignments in the university, I wasn't able to complete those. So hopefully I'll continue on that next week and then start looking for tasks. Yeah.
Oh, I think Tom is sick, so he's got a high fever, and yeah, he's not in the meeting. Okay, we'll skip.
Yeah, so very implement for today, and I'm working on my journal, and I will be available from when I get accepted from my job. Yeah, that's all. I'm sorry. So
I'm sorry.
Verification if the MPR visualization Blender research on the classical segmentator accuracy and develop initial processing scripts SQL instance. Next week, I will focus on the first inference to the script to make sure it's accuracy and explore additional methods.
I successfully integrated the main image model with the local LLM sketching. I was trying to fix the image slider, but was unable to do that, and still not able to scale and position it accurately. So next week we'll be just trying to fix that and some other stuff.
Okay, so maybe before the presentation, maybe Joshua say something, or after his. Which one? After his presentation or before his presentation?
Like,
Just to say, maybe 1 minute, like a message or something.
I think
He already talked. Oh, sorry. Yeah, sorry. He already talked.
I can also more if you want.
If you want.
I mean, what else can I say? I welcome you all in Germany, but I guess you had already enough German internet. So, yeah. Maybe I will be once again in Japan, and then maybe we can see each other again. I was kind of sad that Madeira-san was not here a little bit, but also I was a little sad that I didn't speak, for example, with you so much. But I think maybe you were like a little busy always, seemed a little busy, so yeah. And maybe if I have in the future more expertise or anything, you can also come again and work for West Japan. Yeah, it's a nice area here also. It's a very nice places, but I guess you all know that.
Let's see it again. Okay, then we into the presentation.
Okay. Thank you everyone for being here today. My name is Ramon Vivarte. Today I will explain a bit about NumPy and Pandas, but it's a very brief introduction about these two libraries, not so depth knowledge. So probably for some people here will be a bit boring. I'm sorry for that. But why I want to talk about that, because some people always say that Python is like a compiled language and it's very slowly and it's not the best language. But for me, Python is my favorite language. I really like. And this library specific NumPy and Pandas makes the data handling very fast, improving the complexity of the time and making the size, also improving everything. Well, size normal, yeah. So that's the reason I want to talk about that, to show that these libraries can help Python people to improve the quality of the code. And why I like Python, because it's a language that you can read like a book. Like it's very well written, that it's very easy to program and very easy to understand. And if you do some neat code or something, or lead code sometimes, like Python is like a really good way to do it. So it's my recommendation to use Python. So yeah. So why you want to use NumPy? First of all, you can ask why we don't use just Python. So Python has some limitations, especially in lists, in arrays. So why? So as you know, this it's very normal. It's like Python, you can create an array with different types of values, like ints, floats, everything, right? So Python need to, for every single item, need to know which type of item it is and which space it takes for each item. So it takes a long time. It takes many calculations, right? So how we can do this better? So how we can reduce this? So we can use a NumPy solution. As you know, I know you know, probably know, but it's okay. So why NumPy is so good? Probably use ChatGPT. You just give you the code, but I try to explain the reason why NumPy is good. So first of all, NumPy, you can use only the same type of elements in the array. If you have a matrix, only int. So only, if you have float, only float. That's the first thing you need to know. And the structure is in tuple, right? So in immutable. Tuples are immutable, that is not array. So which attribute you have? The D type. So you have, first of all, which type of the array it is. So it's integer, right? So you already know that the size of this will be an integer. So if the integer is integer of 64 is 8 bytes, so you know that depending on the size of the array, you will know already the size that you can put in your computer, the shape, the dimensions, which is the size of your matrix. So you also have in NumPy this data and the raw memory. I need to store it in C. What means that? What means that in C? So it uses the low performance using the data, so it gets even faster, right? So we have this simple code here, right? The first one is in Python, raw Python. Okay, a simple a square multiplication here. Okay, this simple. Okay, everyone knows to do it. This NumPy. So you use the first function that is a range that do the same. So you put a number of values and you will create an array with 0 to 9,999. So 1, 2, 3, 4 until this value, and NumPy zeros, numerical Python. NumPy is for numerical Python, if you didn't know. So zeros, that goes to 0, 0, 0, 0, 10,000 times, right? So as you see here, you don't have any for loop, you see, and you do element by element multiplication, you see, without a for loop. Okay, so how much faster do you think it will be? What do you think, for example? How much faster, how many time it will take to do what this and this? How much do you think? Anyone have any guess?
And then one?
No, but both. How much faster? How long it would, if you do this time 10,000 operations? 10,000 operations. How long it will take? Imagine that everyone have the same computer. Okay, depending on computer and everything, right? So I just calculate this because a code function that is time meet. So it's 150 times faster in my computer. Okay. That's what I want to say. 150 times faster, approximately. It's not like that, but what means that NumPy is a good a good way, microseconds, that's a millisecond, right? That's what I want to talk about, that why we want to use NumPy. Now I get your attention and I'm saying why is important, how we can create NumPy arrays. So the first thing is you have one day array, like one dimensional array, is like NumPy array, and you put the numbers that you want. The matrix is always row column, so you have 1, 2, 3, so it will be the first row, the second row, 3 row, right? You can do as much as dimensional as you want. And for example, if I put B shape, which shape will be? If I do B shape.
B shape.
B is this one, will be the shape.
2-dimensional.
No, 2, 3. The row columns, ne?
Yeah.
And the size will be 6. Is the number of the length. So it will be 6 number, right? So this the shape is 2, 3 because of matrix, ne? This, sorry. Later we have also, when we have this, what I want to say is you already have pre-computed arrays. So you have the 0, the range that we talked about. We have the zeros that we talked about. We have also ones, that instead of zeros you have ones. And we also have full, what full it is. So you put the row column if you want a matrix. If you want a matrix, you don't need to put like that. And you say, I want this value. So you will have a matrix with this specific value that you put. If you want, the I is the identity matrix, so you put, for example, 3, you will have 1, 0, 0, 0, 1, 0, 0, 0, 1. You have an identity matrix when you want to make some cool stuff, right? And finally, you have line space that you probably already use many times, that you have like a start value, a stop, the final value that you want, and you put the number to a slicing. For example, 0 to 9, 10 times, so 0, 1, 2, 3, 4, 5. And this is in float. You get floats because you need to understand that normally you have a small error when you create, for example, 0 or something like that. You have a small error that goes bam, bam, bam. So it's sometimes a little bit error on that. You need to be careful. Yeah.
Can I ask a question? Are these arrays dynamic, or is the size always the same? Like you cannot change the size of the NumPy arrays.
NumPy arrays,
Yeah.
you can add values on NumPy
You can-
arrays. Yeah,
okay.
yeah. You can say it's not a tuple. It's array. It's not a tuple. If you have a tuple, yes, you cannot change because it's a tuple, right?
Yeah.
But it is an array. An array. As you can see here, if it's a tuple, will be in parentheses like that. So yeah. But you need to be careful. You need to be careful as always. You know that this is, for example, you have a ones and you can create a Boolean array with that. You can create 3, 2, so it will be true, like row for rows, right? So later you want to compute in integer, okay? A simple integer, so you want to have 1, 1, 1, 1, 1, 1, right? What is the problem of that? So you already know, but I talk because it's my presentation. So you need to make a copy. When you make a copy, it's takes a lot of computational expenses because, as I said before, Boolean is 1 byte, right? 1 byte. So you take as a specific range, and you want integer. You need to make a copy. Find where the space it is in the computing, and put. Okay, I want to find first of all the size that I need for this, and copy my string. So it takes a lot of time. So this is a good practice. Try to don't copy the matrices. Okay, this is my recommendation. But it's sometimes it's hard. I will say. I just say that it is good to do. Don't make copies of that because it takes time. What you can do is persistence. But persistence is a very cool stuff in NumPy. What it does that. You can have a matrix. You can save the matrix. You put is normally NumPy. You put the matrix that you want, the array that you want. You can save, and then you can use everywhere the same matrix that you have, like by loading the matrix. This is very cool stuff because you just can save in like in a file, right? And everyone can use your data like that. So this is pretty cool. It's my recommendation. So why so fast? Why is good? Because the basic arithmetic operations perform element by element, and vectorization handles the loop that you do for doing matrices internally in the CPU, like boosting the maximum performance that you can get. The second thing is, for example, it does it does this out by what's called parallelization. So imagine it takes 16 values. You have an array, for example, of 100, the first 16 values, and perform this in once. Bam. The second in once. It does one by one. It takes the whole bunch of some data and do it by what's called parallelization. So it's pretty fast. The second, and this is amazing, NumPy can distinguish between element-wise and matrix multiplication. As you can imagine, it is very good. You just put add and you can have the matrix multiplication. And a cool stuff that also have this, if you do it for yourself, for example, if you do want to make a multiplication, a matrix multiplication, you need to have, okay, for the rows, for the columns, do this multiplication, right? You need to do double for row, that will be n per m, for n is the number of rows and the columns, so it will be, you can have n per m or n squared, depending on how you want. So what happens? But NumPy will do is take for each row, it puts all the rows in just one row, right? So it takes, if you have 5 rows, just moving one, and do the operations in ON. That is the length of the matrices. So this improves the performance a lot because you are doing just in one single array, right? So this is a lot of faster than you can think. That's the reason that people use NumPy. People sometimes use NumPy, but they don't know why NumPy is so good. That's interesting, man. The second thing is very cool stuff. This is like Python, I will say. You have you create the matrices like that. You get 16 values. You reshape. You want the matrix size, and you say, okay, give me the row 0. You just need to put the matrix and row 0. You get the row 0. Right? This is simple as Python. Okay, if you want the column, you just take from all the rows. Give me the column 0. So you will get the column. Also, this same as Python notation, a start, stop, step. So I want from the row 1 into row 2, and from the column 1 into column 2. So you will get these values, right? This is the same as normal Python. If you want to say 1313, you know that they start by the 0 to 0. It will be 0 to 3, no? And the 3 means always you take the last value. Like it's not 3, it's 2, the index. Also, this really cool. I put fancy indexing because I think it's pretty fancy. So if you just want one value, you can pass like a list like that, a tuple like that, and you can get the specific value 1, 5, and then returns in array. That's pretty cool, I feel. You can get a specific value by putting the indexes that you want. Pandas. So yeah, we talk about NumPy. We talk about how NumPy is very useful for do some cool stuff, for memory, for EUC, so it gets a good memory. I didn't calculate the memory, but definitely it's what says the literature, so good memory, good speed. But do some mathematical stuff, right? So, but normally we work with like CSV file, common separate values. We work with Excel. We work with SQL. How we can process this data with NumPy, with other. So this enters the library Pandas. Panda is what it enters here. So basically, NumPy is also a very optimized library for the last 10 years, 15 years. I don't know, like same as almost NumPy. So pretty optimized library. That is it's very easy to use with a very good data structure, simple to use, and basically it helps when you have labeled data. So normally in CSV files you have the header, right? So the header, it comes blah blah blah, and later you have the columns, right? So very intuitive way, and it's used for Excel and SQL, and also use NumPy. So a vectorization, so a very fast way to retrieve the columns, to retrieve the data that you want. Okay, so how you will load. So now that you know that I want to use Pandas because I convinced you that Pandas is a good library to use. There are other libraries, okay, many libraries. I don't have here, but there are other libraries that you can use instead of Pandas, but I think Pandas is the best. So basically, you can import URL, import Pandas as PD. Normally, this is the standard thing. You never will find like pandas.csv is important to always have consistency with other people. And you just put, for example, I load the URL, visitor head, and you have the 5 rows. So you have the 5 first information that you have. So you will know if it's an integer, you can have different data because visit.info shows the data types and the non-missing values from each column. Okay, and the describe prints the statistical summary, the mean, the max, the standard deviation, and for the numerical column. So if you have 0.5, everything, you will get all this data. Okay, so now you know a little bit which structure have pandas, what you can, like how you can interact with the data, how you can move around the data. So there are two main data structures, the series and data frames. We will start for series. The series basically is the columns that you have. For example, you have fishes and you have type, for example, fishes type, white fish, for example, or whatever, I don't know. So basically, you just put fishes and you put the string that you have, and you will get all the fishes that have the same type, right? All the column of the type, not the same type, all the column from this specific type, right? Second, the pandas data frame. The pandas data frame is all the data that you have in the table in your data. This data frame, and it have the column, so the time, the weight, and the index. The index will be the zero index row. You know, so for example, can be the names or numbers. For example, if you have, for example, 100 fishes and the name, for example, salmon 1, so you will have this data there, or salmon 1 or whatever you have. So how can I select data? You can select like that. So there are different methods that you can do. Log. You put a level name, for example, from the specific index. For example, index name, for example, salmon 1. Give me the type. The type. Okay, is I don't know, like what? I don't know, is like tuna. I don't know, whatever, right? So you have the type. You have ilog. So I want for the zero column. I also assume the fifth index. So you will have also this data. You can do a slicing. So for the index name, I want this data, and you can do the same with the ilog. Okay, with indexes. Later we have here the data manipulation. Okay, so first of all, imagine that okay, I have a few fishes with fishes because more than one type of fishes, right? Fish, it can be also plural if you have, for example, the same type, but fishes is for more than type, but whatever. So I want all the fishes that their weight is bigger than 70 kilos. So you will have all fishes that have this weight. Okay. Also, missing data represented by NumPy. It is very important. Many times when we are working with data, they are missing not a numerical, I think it is, not a number, I think it is means none. So I have this NumPy, not a number values, and I say, okay, return me if this is a none. So you will have return a boolean to mask if there are data missing there. Drop now, remove all the rows and columns if there are a specific value that is not a number. Also, if this is not a number, I want to put, for example, 0, because I don't want to have an error. Okay, I want everything integral. You put 0 and fill now, for example. So you have the last value was 70 and the next one is not a number. This not a number will be 70. Okay, if you put f fill. Okay, as you can see. Okay. Well, I'm going so fast, talking so fast. Oh my god. Okay, so other operations and analysis that you can do in pandas. Okay, that's very interesting thing. The first one is group by. Okay, this is an important feature that allows to split the data and apply functions and combine the results. What do I mean by that? Okay, you can apply min, sum, max. Okay, so imagine that you want to know. You want to group the fishes by type and location. For example, I want to know the fishes in Hokkaido, Okinawa, and which type of fishes they have. But I just want to know, I want to have the weight of these fishes. So how you do it? You group by type and location that you want, and you put the weight, and you do the mean of that, and you will say, okay, I have the mean of all the values on this specific location and for a specific type, and you have these grouped values. So this is very powerful, I feel, when you are working many data and later you want to use, for example, PCA algorithm, or you want to do other things, you can use these to have like the first visualization of the data, and you can visualize and you can do cool stuff later with Matplotlib, for example. Okay. That's an interesting thing to do. Later, what we have here, other operational analysis, joining tables. Wow, that's pretty good. Why? Because concat and static data frames top each other, for example. What I mean by that, if you, for example, have a data, you have 1, 2, 3, and you have another data frame that is 4, 5, 6, you concat these two tables and you will have 1, 2, 3, 4, 5, 6 in a single data frame. That's pretty good. And merge on column, for example, if you have name in the column and to have the same name, you can join by the specific name. And later, instead of growing vertical, it will grow horizontal in this case, right? Column is a name. You can put any name here. Other thing, very interesting. Tiny data. What is the tiny data? When you want to analyze data, it's important to have a good shape of the data. It's very important that when you want to analyze data, first of all, we need to clean the data. We need to put the data correctly. We cannot use data directly. First of all, we need to understand the data that you want. Okay? So how we can do that? With Melt. Melt is a really good library. So you can say you have this data runners, and this is the meters, and this is the time. So the runner one for 400 meters, 64 seconds. Okay. So, but this is a little bit hard to analyze because the 400 and 800 it is in the head, right? So you don't want to have head. So if you use Melt and it is a dictionary. This is a dictionary, right? So you can put the runner. I want this. I want that the distance it is this, and I want like by assigning of the dictionary, right? So it's pretty good that. And also we have the last interesting, I will say, is like the opposite of what we did that. So we have pivot. So country, category, count. This is a little bit, you can say, oh, it's good, but you can group this and say, instead of that, put the chemistry and physics and the things in the top, right? So you can use the pivot function and you will say, okay, this is easy to analyze. It's like, it's easier when we visualize that, just for visualizing data. When you want to get data, you can say, okay, from USA, tell me the chemistry, how many chemistry they want. So when you use pandas, it will be easier to get the information. And I speak too fast, but if there is any question or anything, feel free to ask now. Yeah.
I think we know that you work in kind of a space field for your research. How do you use maybe NumPy or pandas?
So, for example, I use visualization, but when I work, I create a quick look for the temperature of the camera of the space. When they arrive in binary, we convert that. We need to get very fast. I like C++, so C++ is probably better, but I use pandas to get the information as fast as possible to visualize the data. And what is cool about Python, there are many libraries. So I use, for example, some UIs. So to bring the data to the UI, also need a fast thing. And to pandas, what is good also that you can use it with Matplotlib, right? You have the data, you can convert this data in data frame, and you can put this data frame to Matplotlib. Later you can create the plots very fast, very fast. So I think this joint conversion can do. Also, I'm working more in PyQt, that is like IPyVista, and Visualization Toolkit, that is for visualizing, like for analyzing like visualization, for example. There is this cool libraries that permit, like, that are worked. Many libraries, what they have is they are built in NumPy. How they work inside is with NumPy to make it fast. So I'm working in PyVista that is based on NumPy. Is BTK Toolkit. I don't know if you know. BTK Toolkit is like a 3D analyze and 2D visualization library. So they create an NumPy that is like taking these libraries from visualization toolkit, put in Python, and in Python they are working with NumPy data. Yeah. I think it was very just introduction, so probably everyone knows everything I saw, nothing special, but I don't know what to talk. Many functions. One thing it's pretty interesting is that in here in NumPy, what you can do is make a mask on that. For example, if you do you write like a tuple and you say A, imagine that it's called A, this matrix. A is bigger than 0. This convert, all of this will be false, true, and you will have like a Boolean mask on that here, like that. You can also do that. That is pretty powerful, I will say, getting a mask on Booleans. What I can say more here. Here, everything is processed in C. That's an important point. I don't know. You have any question? Please, any other question? Probably easy for you guys. Thanks for you.
Well, yeah, for me, it's like not that easy, maybe. So, I would be interested in more like the general explanation, very briefly.
Yeah.
But because I don't know both of these.
Yeah.
But some of it I understand because I also had some of coding courses, coding lectures in Java.
Oh yeah.
But, I kind of engineering mostly, so just very briefly, how can I?
And bro, okay, do you like that data science or like something like that? Because so basically, when you have like data science, there are many, or AI, for example, SQLearn or anything. Normally, all of this is built in these libraries. All these AI models normally are built in this in NumPy, because if you use Python, it will be so slow, and already it's a little bit slower than Java. Java is pretty fast, right? Oriented objects. So basically,
and NumPy is just like the library that you can also include into Java, for example.
No, I don't know. I don't think so. NumPy is just for Python. Numerical Python. It stands for numerical Python. It's just to instead it's for vectorization. It's most important is vectorization on this part. This part here. In Java, I think you also can use pointers in Java. I forgot. You can use memory, right? Python is like a compiled language, which means that first it's like hit a like first go, first out, right? It enters them the memory, and you can take them. It's allocate the memory automatically. You cannot decide where the memory goes, right? So it's pretty inefficient because like how you like. What can I say? You need to understand where you want to put the data. And later take the same memory that you want. It will be faster if you already know the memory to get the data, right? You don't need to find the data again where it's located. So this is pretty slow. But NumPy, what it does is try to improve this with vectorization. You already know the type. You don't need to find the size that you want, like of the array. You already know the size. You already know the data that you want to put in this data, like that.
So I have only one question. You saw the time calculation?
Yeah. Timing. Yeah. It's called in NumPy is if you do 10%, like 10%, time it in a cell. If you use Jupyter notebook, you will get the time that takes to do this operation, and I think it does like 1,000 operation for each cell. Like if you have this, it will do 1,000 operation.
So my question is, if I have to calculate condition.
Okay.
So if else case. So which one perform better? Because
Definitely NumPy will perform better.
but NumPy is for like
For example,
okay, for example,
uh,
it takes the whole array, like 10,000 array,
yeah,
and it parallelly
you can make a if
change the like value. But if I have to check like for every iteration, so
yeah.
will it be possible to do?
Yes, because say like I explained here, you can add ifs here.
I can add if, but will it be
No.
like same faster or
No, first of all, it will be faster. First of all, this is computed in the CPU, right? If you do a program, normally it's not in the CPU. Normally, when you run a program, and depend if you can specify, right? Do it in the CPU. You can specify by yourself. And the second thing, this makes the thing also makes faster is because it's doing C in the back is programming C NumPy, and the second thing that is important is that it's doing what it's called. This every operation, if you have the if and everything, it will be computed in parallelization. Understand? If you use parallelization on this, you will have 16. You will perform the if and all these like this all the information.
at the time 16 if case?
No. But how can I say this here?
I
This
think,
here.
I think Newman's asking if it was not an array that we were
What
like a singular value, and he's asking if there were like
a single value?
multiple if statements.
Yes.
Would it be like
No,
the
because
same performance,
normally
or-
NumPy is normally you don't have. Normally, it's based on for arrays and matrices.
Yeah,
Okay,
that's
so
what
that-
I'm.
yeah, he's asking.
No, because you will have the same. I think so. Probably if you want to optimize that,
If you have many if case like condition,
uh,
I think this time the like normal Python will be better than NumPy.
I'm not 100% sure on that.
Maybe you can check.
Yeah, I will check. But if you want time complexity, you can change the integer to be integer 32, for example. You will not have this like quality, but it will be like also pretty faster because you will have less memory. So of course there are many ways to optimize this Python. It's just an example of these operations, but yeah, if you want optimization, I recommend you reduce the quality of the data like that. Yeah, that's so. Thank you so much for your time.
Lyrical feedback fiction.
I hope you didn't get bored. I need to do it.
Okay, just render a blank message. Or you can just prompt please say good. That's too.
Ens vam conèixer fa temps, era batxillerat. Tu em vas tirar la canya, jo la vaig agafar. Sempre de flor en flor, però amb tu jo em vaig quedar. Comença una història que no té final. I és per això que avui som on volíem ser de petits i ho hem aconseguit. Per moltes coses que ens passin, jo t'estimo igual. Jo t'estimo igual, potser més que mai. Per moltes coses que ens passin que no acabi mai. Som el millor tàndem, l'equip ideal. Per moltes coses que ens passin, jo t'estimo igual. Jo t'estimo igual, potser més que mai. Per moltes coses que ens passin que no acabi mai. Que no acabi mai. ets el meu millor públic, et miro i em tornes boig. Saps que jo adoro el que fas perquè és únic. I és per això que avui som on volíem ser de petits i ho hem aconseguit. Per moltes coses que ens passin jo t'estimo igual, jo t'estimo igual, potser més que mai. Per moltes coses que ens passin que no acabi mai, som el millor tàndem, l'equip ideal. Per moltes coses que ens passin jo t'estimo igual, jo t'estimo igual, potser més que mai. Per moltes coses que ens passin que no acabi mai, som el millor tàndem, l'equip ideal. Ens vam conèixer fa temps, era batxillerat. Tu em vas tirar la canya, jo la vaig agafar. Sempre de flor en flor, però amb tu jo em vaig quedar. Comença una història que no té final. I és per això que avui som on volíem ser de petits i ho hem aconseguit. Per moltes coses que ens passin jo t'estimo igual, jo t'estimo igual, potser més que mai. Per moltes coses que ens passin que no acabi mai, som el millor tàndem, l'equip ideal. Per moltes coses que ens passin jo t'estimo igual, jo t'estimo igual, potser més que mai. Per moltes coses que ens passin que no acabi mai, que no acabi mai.
I don't watch the news.
77 30
Okay.
I ne
Really?
da.
Okay, well, let's wait a little bit for the ETS generator. Does he want to be lifted up? I'm not sure. Did this want? I'm not sure. Honestly, I don't think it's enough.
I think maybe enough.
Enough. But if he wants to be like a, I'd say it's lifted edition. That's very well.
The feedback provided for the presentation on Numpy and Pandas was generally positive, highlighting the presenter's enthusiasm for the topic and the informative nature of the content. However, there were consistent mentions of the speaker speaking too fast, which made it difficult for some audience members to follow along. Suggestions for improvement included slowing down the pace of speech, providing more live examples, explaining concepts in a clearer manner, incorporating real-world use cases, and enhancing the presentation slides for better contrast and content organization, or overall. The audience appreciated the depth of the material presented, but felt that it could be better communicated and demonstrated for better understanding by a wider range of viewers, including those less familiar with coding languages.
Like the branching between the
Okay, so
the audio AI speaker. I think we should do Yoshi. Huh? What were we talking about?
by remoting.
Yeah.
Yes, that's
We were talking about.
No, it's okay.
Oh yeah,
I think it's okay. I think
You sent her
I'm going to email. Victor, can you hear me?
Yes, I can hear you.
I just want to confirm if we send the slides.
When I saw the message, I sent the email. Yes.
Okay, thank you. And then they want to bring some Japanese language paper or something for the audience?
We prepared English and Japanese on the slide.
Okay.
So the slides are in Japanese, yes.
Okay. No problem. Thank you so much.
Thank you.
And then I saw the paper. Thank you on my desk. Thank you.
Bye.